Here's problem 1427. A wood block is placed on top of ice in a large bowl half full of ice. The bowl is then filled to the brim with water, with the wood block riding on top of the ice. As the ice melts, what's going to happen? So let's take a look at our container here. And let's look at the point where we've added the water and the ice is floating in the water. So we got ice partly out of the water like this, and there may even be ice on top of the ice floating in the water here, and on top of that is our wood block. So if we look at all this stuff that's floating, it is displacing an amount of water equal to its own weight. In other words, it's got weight, but then there's a buoyant force on it equal to the weight of the water that it is displacing. And even as the ice melts, the ice will replace that volume of water with pure water. Ice is water, and there will be no change in the displacement of the water as the ice melts. So in the process of the ice melting, the water level will not change. Now if the block is less dense than the water, then the ice can melt all the way and still the water level will not change. The ice will just replace the water that was being displaced before, and eventually the block itself would float in the water, displacing a amount of water equal to its weight, and the water level would not change in that case. However, there is one possibility. If the block actually weighs more or is more dense than the water, then at some point after the ice is melted, it may sink into the water. And at that point, it will only displace a volume equal to its own volume, not a volume equal to the weight of the water or the water that would equal its weight. So it will be displacing less volume than it did before. In that particular case, the water level would actually go down a little bit. But in the gist of this problem, we're talking about as the ice is melting, and hence we're in this case where the ice is still displacing water, and if that's the case, then the water level will not change.